Okay, 7.1, number 54, we've got a definite integral right here, and our integrand has two different parts. We've got a simple polynomial followed by a trig. So according to Lippitt, we're going to let u equal the polynomial part of the function, which is just x, dv being everything else, the cosine of pi x dx. Du then simply becomes a dx. Integrating this cosine of pi x over here, integral of cosine of an angle is sine of the same angle divided by the derivative of that angle, which is just pi. So the original integral then right here is equal to our u times our v. I combined the x and the 1 over pi to make a 1 over pi times the sine of pi x, and then minus the integral of v times du. So I pull the 1 over pi as a constant out in front of that integral, and then we've got sine of pi x dx. And that new integral definitely looks easier to evaluate than the original because the monomial, the x, is gone. So from here, we're in pretty good shape now. We take the original u times v and leave that alone. And now, integrating sine of that angle, we're going to get negative cosine of the same angle divided by the derivative within. The negative combines with that existing negative to make a positive. The 1 over pi gets divided by pi again to get a 1 over pi squared. And then we've got cosine of the same angle. And you'll notice now I put brackets around the whole thing and evaluating it from 1 to 0. All right, so putting the 1 in first, all the x's become a 1. We had just a sine of pi and a cosine of pi. And then putting zeros in, the 0 over pi makes this whole term here just become a 0. And then plus 1 over pi times the cosine of 0. Okay, remembering here that the sine of pi is equal to 0, that wipes out that term. Cosine of pi is negative 1, which makes this term a minus. Over here, on the second part of it, from putting in the 0, we are doing the cosine of 0, which is 1, and we end up with this. So it's a negative 1 over pi squared minus another 1 over pi squared, which gets us a negative 2 over pi squared.